Welcome back to the iSquared podcast, where interdependence meets impermanence, and we explore profound philosophical ideas that can change our perception of life. In the past episodes, we have dived into the concepts of interdependence and impermanence. Today, we journey into the fascinating world of infinity, guided by a special guest who will help us see the connections with the other I concepts. Before we dive into that, let's briefly recap what we have already learned so far. Interdependence taught us about compassion and understanding the interconnected causes behind actions. Impermanence, on the other hand, inspired us to embrace the present moment and sparked creativity by acknowledging that we do not last forever. Now, let's set our sights on infinity, a concept that might seem abstract, but has a deep connection to everything around us. And who better to help us explore this than our guest mathematician, an expert who has spent years unraveling the mysteries of numbers. Infinity, it is a concept that both intrigues and perplexes us. In mathematics, it represents something without any bound, limitless. But in our daily lives, how does infinity touch us? How does it intertwine with interdependence and impermanence? We have a special recording that I captured earlier, an interview with our first guest ever on the show, Dr. Tomas Veloz, a professor from the Free University of Brussels. In this interview, Dr. Veloz wonderfully connects the dots between infinity, I as imaginary number, interdependence, and impermanence. Let's listen. Welcome, dear listeners, to the highlight of today's episode. With us is Dr. Tomas Veloz from Free University of Brussels, a specialist in mathematical modeling and complex systems, who has also explored the relations between philosophy and mathematics. Dr. Veloz, thank you for joining us on the iSquared podcast.
Thank you, Jimmy, for inviting me here. It's a pleasure to speak about these interesting topics.
Dr. Veloz, let's start with infinity. Can you provide us with a simple yet profound understanding of what infinity means in mathematics?
Understanding infinity is actually a very beautiful process for a mathematician, because before we start, we all have this idea or illusion that we start thinking about infinity as something mentally unreachable. We think of how big is the universe or where it ends, but at the same time we can think of how little is the micro-universe if we have access to a microscope or to some sort of device to look at the smaller scale. We come with these questions, and then mathematics indeed provides at the very beginning a notion that it's actually contradictory to the notion of infinity, which is the notion of limit. And the limit is the way in which we can access to infinity, because our only way known at the moment to get to understand infinity is through a process that makes a step at each time, and we conceive the infinite as the limit of such a process. So if, for example, we want to reach normally we get taught in the first case, the infinitely small. So we want to reach the infinitely small. How do we do that? We have to look at something and then look at it closer, and then closer and closer, and so on, closer and closer and closer. And the limit of that process of looking at something closer and closer will be the infinitely small. Similarly, if we want to get to the infinitely large, we have to go to a process that increases and increases and increases. So then we don't access to infinity as such as an object, but we construct it as the limit of a process, either of growth to reach the infinitely large or the infinitely small through a process that zooms into a specific pattern.
Fascinating. Now, let's dive into imaginary numbers. What are they and why are they essential in mathematics?
Yeah, imaginary numbers. In order to introduce them, we have to go back again to the notion of construction, which is extremely important in mathematics, about stuff that is very hard to think about. So in general, we need to do intermediate constructions or steps to get to these more complex ideas. In particular, the imaginary number, it's represented by a number I, and this number is actually the solution of an equation, of a mathematical problem that states the following: what number multiplied by itself will give me as a result the number -1? This problem struggled mathematicians for centuries, because for numbers like, for example, 9, we know that for number 9, the number that multiplied by itself will give us as a result the number 9 is 3. So the square root of 9 is 3. Same with 16, we get that 4, because 4 times 4 is 16. With 25, we get that 5 times 5 is 25. So and actually we can solve the square root of every positive number. Every positive number has a square root, and it's very easy to calculate. There are ways to do that, and that's another mathematical problem, how to get that, but there is a simple solution. For negative numbers instead, like what's the number that multiplied by itself will give us -4, -7, such a solution does not exist within the numbers that we are accustomed to think of. So that's why the number I was created, because it is the solution of that problem for the most fundamental negative number, which is -1. So the square root of -1, it's I. So then the square root of -4 will be 2i, because 2i times 2i will be 2 times 2 times I times I. I times I will be -1, and 2 times 2 will be 4, so then that would be 4. And that's how we come to this imaginary number. But then later on, that's the funny thing, that it was understood that this number is intimately related with many deep aspects of mathematics and geometry, especially with geometry, with the idea of trigonometric functions and oscillations. So this was the extremely interesting thing, that something that was meant to be just a solution of a simple mathematical equation that had no solution for centuries, but nobody thought that would be so profound, was later discovered to be related to the analysis of signals, earthquakes, frequencies, motions of stars, and the states of atoms in quantum theory. So it's extremely fascinating, everything that came out of the number I. And for those that are more interested in looking at specifics, I will suggest you to look at the Euler equation of expressing I as a cosine plus sine functions, because this is related to the depth of motion in space. So yeah, it's very, very interesting concept.
That's intriguing. How can we relate the concept of imaginary numbers to the theme of interdependence? Is there a connection there?
Yes, definitely. Imaginary numbers and interdependence have many, many connections. As I was saying before, imaginary numbers were discovered to relate very profoundly to the notion of circularity, because they construct imaginary numbers together with real numbers. They construct what is called as the complex plane. And in the complex plane, every point represents the sum of a real number and an imaginary number. But they all together are interconnected through this formula that I was explaining before, the trigonometric formula that connects points to cycles. So I will say that interdependence has an intimate relation with the notion of cycle. When everything is connected, there must be a beginning and an end to this connection. Even if we think of infinite objects, they are always connected back to each other, maybe directly or through a third link or a fourth link or a fifth link or an infinite amount of links that they have to go through to come back. So I will say that the first space in mathematics where we can see this property that everything can be interconnected in intricate but interesting or necessary ways to impact each other is the space of complex numbers. That would be one geometrical and simple way to establish shapes of interconnection, as it happens in analysis of these spaces, where we can observe the relations between certain points might be there is an infinity of other points interrelated to these 2 points that we were first looking at in very beautiful ways. This appears very much in complex systems analysis, where we can observe through these simple formulas on interdependence. So that's one way, the geometrical way in the complex plane. The second way, which is a little bit related, is in something called Fourier analysis. In Fourier analysis, we take any signal, anything that vibrates in the universe, and we will express it again using complex numbers. The same complex functions to express all possible vibrations in the universe, given some constraints that are technical and I don't need to express here. For example, a sound that lasts for a given time, let's say 3 seconds. That sound and any other sound will be expressed in terms of some specific complex functions, and the way in which they differ is because these different basic complex functions will have different values together with them. Some of them will be stronger than others, but it will be the exact same set of complex functions expressing all the possible sounds. If we take earthquake signals, for example, the earthquake's shapes are very strange. When you look at the patterns of movement of an earthquake, it's very different. These are very different from each other, but they all expressed by the same set of fundamental complex functions. With sounds is the same. If you look at the signal of a sound, all sounds look differently in what their signal shows, but they all are the sum of the same basic functions. This is called as Fourier analysis, and it is another way to relate interdependence of patterns of vibrations with some fundamental forms in the imaginary plane and the complex numbers. And the third one, which is the deepest one, is the notion of quantum entanglement. In quantum entanglement, we describe the interdependence, which is impossible to break. It's the strongest possible form of interdependence between quantum objects. Expression of entanglement in mathematical terms requires the use of complex numbers. So actually, if we will not have imaginary numbers, and we will have created quantum theory without imaginary numbers, we will never have discovered entanglement and neither interference. So actually, that's maybe the strongest form of the relation between interdependence and complex numbers, because in quantum theory, the complex numbers are actually essential.
Wow, Dr. Veloz, this has been an eye-opening conversation. Before we conclude, is there anything else you'd like to share with our listeners about these concepts and their deeper meaning?
Yeah, sure. So all this conversation to me has been very, very eye-opening as well. And I would like to share a more personal philosophical thought about the relation between impermanence, interdependence, and mathematics, which is that traditionally in Western thinking, we tend to think that science and the understanding of the world is basically meant to be on describing objects. So we got the sun, we got the moon, we got our house, our car, and we got objects. And objects describe what we are, what we do, and what life is about. And in physics in general, and in biology, we also think in terms of species, in terms of planets. We give a lot of attention to the notion of object, to describe the world and to think about what are we doing here, what's all about. But when we open our mind and we think that beyond objects we have processes going on, like for example the process of motion of the moon around the earth, that's not an object necessarily moving around. It's more important than there is a process of motion than the very fact that there is something moving around. So the process of motion is more important than the object that moves. If we put more attention to the process, we will start seeing that there are multiple and millions of processes around us all the time. And now that we know something in mathematics called as chaos theory, that we know that the impact of very little happenings in one place can affect very strongly the happenings at some other place later on, will allow us to think that maybe the movement of a leaf on a tree, or the flying of a butterfly around us, or that the blink of an eye of a neighbor person around us can be as important as any other thing that is surrounding us. Maybe like the power of gravity of another planet, or our own internal health state. So if we start thinking that interdependence is really a thing, we need to come to think about the notion of process and not just of the notion of object. And that's why imaginary numbers are so important, because they embody the most fundamental way to describe a process using mathematics through this description I said in the complex plane of the cosine and sine functions that they move around, creating a circle. So that's the most simple way you can describe a process using mathematical formalism. But then when we come and start thinking that processes are the real fundamental objects of reality, and there are so many going on and all interdependent, we kind of give away the notion of object, and that's my suggestion, give away the notion of object as the central element of construction of reality. So that will be my last conclusion. Thank you, Jimmy.
It is a very fascinating idea, Dr. Veloz. You know, according to Buddhist tradition, the notion of no self, no object, no subject has been taught for almost 2,000 years. In the 2nd century CE, there was a monk philosopher called Nagarjuna who really looked deep into the concept of no self, no object, no subject. In the teachings of Buddha, he taught us that when we examine carefully, everything in the world has no solid existence. Everything is only phenomena. That's why everything is empty. And this notion of only phenomena is also described by a physicist, a theoretical physicist, Carlo Rovelli. In his latest book, Helgoland, he talked about the physical world as relationships between particles. There is no solid particle existing, because when we actually do experiments to look for particles, what we found are only interactions. We have never found any solid in the realm of quantum mechanics, and that is really fascinating.
Yeah. Indeed, when we look at quantum mechanics, it's when these aspects manifest like in a way that we cannot even like build a theory without taking this into consideration. Um, but I would like to move it forward, not just in quantum theory, because people in general have a struggle understanding this, the micro world and all what happens at that micro level, and whether or not will impact us in this macro world that we live at. So it's the quantum world, I will say, it's a sort of oracle for our understanding of reality, but it teaches us that the stuff we see there, contextuality, superposition, entanglement, and all these properties, they can also be found in the macro world. And actually, I have done some research trying to connect these notions to the way we think about the world. And indeed, it is fascinating or shocking that when we think irrationally, according to our current understanding of what rational means, when we think irrationally is when we think in an interdependent way and when we incorporate elements of the infinite into our reasoning. So everything that is related to emotions and that makes us act in weird ways, as we say, emotional ways, because it's not rational way, it's exactly the moment where we manifest our, let's say, quantum power or the quantum features in our behavior, in our thinking. So these aspects that we are touching upon in this conversation are actually very new science. These are things that have not been yet understood in mainstream science, and this is why I found them so fascinating. So thank you, Jimmy, for this opportunity.
That was the conclusion of our interview with Dr. Veloz, but our journey to infinity and the imaginary has only just begun. Thank you for tuning in to the iSquared podcast, where we stand at the intersection of infinity and the imaginary. After the break, we will take these concepts out of the mathematical realms and see what lessons we can learn from them in our lives. Welcome back, my dear listeners, to the iSquared podcast. Now, let's take a closer look at infinity. Consider a droplet of water in the ocean. It seems insignificant, yet it is part of an infinite, interconnected web. Each wave, each ripple, influences another, just as our actions are interwoven with those around us. But the idea of infinity in interdependence doesn't even stop at the ocean. Think about a family tree, extending branches and roots in all directions, connecting us to ancestors and future generations. It is an endless network of relationships filled with compassion, understanding, and connection. Let's embark on a thought exercise together. Consider your parents. You have two of them. Now, go back one generation to your grandparents, and you will find four. If we continue this pattern, doubling the number of ancestors with each generation, we will soon arrive at numbers that boggle the mind. In just 10 generations, you would have 1,024 ancestors. How many of them do you know, by the way? Now, go back 20 generations, and the number grows to over 1 million. reach 30 generations, and you are looking at more than 1 billion ancestors. The numbers expand so rapidly that very quickly no computer can handle them. And here's where it gets even more profound. These numbers represent only a tiny fraction of the innumerable interactions that produced you. Every smile, every handshake, every decision your ancestors made rippled through time to culminate in your existence. You are not just the product of your parents, but the infinite number of interactions produced over the entire existence of the universe. And it goes for every single human being alive today. All 8 billion people, we all share an infinite ancestry together. Think about that family gathering, a wedding, or even a chance meeting at a coffee shop that might have set the stage for your lineage. These interactions are like threads in an intricate, boundless web, connecting us to something much larger than ourselves. And it doesn't stop at our ancestors, my dear listeners. Our actions, our choices, our connections extend infinitely into the future, influencing generations yet unborn. It is a network of relationships that is endless in both directions, filled with compassion, understanding, and connection. The concept of infinity here isn't merely numerical. It is a symbol of the boundless nature of our existence, our responsibilities, and our potential to love and to connect. By understanding our place in this infinite web, we can embrace interdependence in our daily lives and recognize the profound impact we have on the world around us. It is a perspective that is both humbling and empowering, grounding us in the present moment while connecting us to the vast expanse of history and future. In that infinite connection, we find not only our roots, but our wings, an understanding that helps us soar into a life of deeper compassion and purpose. Thank you for being here on the iSquared podcast, where infinity manifests itself through interdependence. Stay tuned as we continue to explore the enigmatic eye, the imaginary numbers. Dear listeners, as we venture further into the landscape of our exploration, we find ourselves at the crossroads of impermanence, imaginary numbers, and interdependence. These may seem disparate at first glance, but they are, in truth, intimately entwined. Consider imaginary numbers, those fascinating mathematical entities that exist beyond our real plane. They are akin to the gentle wind that brushes against your face, unseen but palpably there. These numbers might seem abstract, but they are present in various fields like electrical engineering, physics, and even in the waves that bring music to our ears. Imagine tuning a radio. It is the dance of real and imaginary numbers that allows you to hear your favorite song. It is a connection between the unseen and the seen, the abstract and the concrete, bridging gaps we never knew existed. As Dr. Veloz explained to us, imaginary numbers are numbers with a very peculiar property. They involve the square roots of -1, something that doesn't have a clear meaning in the realm of real numbers. When you square an imaginary number, you venture into the negative territory. This very nature makes them a continuous dance between the real and the imaginary, the concrete and the abstract. These numbers, always transforming and flowing, mirror the ever-changing nature of our lives. They find applications in quantum mechanics, where particles are never in one state, but in a superposition of states, forever shifting and evolving. To truly grasp the dance of imaginary numbers, let's dive into their role in something as everyday as rotation. Picture a point on a plane, moving around in a circle. How do we describe this mathematically? In the realm of mathematics, we often use complex numbers, which have both a real part and an imaginary part. These numbers are instrumental in describing rotation, and here's how it works. Think of a complex number as a point in a plane. The real part of a number represents the horizontal axis, while the imaginary part represents the vertical axis. Together, they define a location, like a dot, like a drop pin, a coordinate on a map. Now, when you multiply a complex number by the imaginary unit I, which is the square root of -1, something magical happens. The point rotates 90 degrees counterclockwise. Multiply it by I again, and it rotates another 90 degrees. It is like turning a key or spinning a wheel. Every multiplication brings a new 90-degree transformation. This concept might sound abstract, but it is actually at the heart of many modern technologies. When engineers design systems for signal processing or control the movements of robots, they often use complex numbers and the principles of rotation through imaginary multiplication. So, these imaginary numbers are not merely abstract concepts. They are tools that allow us to describe the turning, twisting, and twirling of objects in space. It is a constant dance between the real and the imaginary, a dance that reflects the transient, ever-changing nature of everything around us. Dear listeners, as you turn the steering wheel of your car or watch the hands of a clock move, remember the imaginary numbers and their eternal dance. It is a beautiful reminder that everything in our universe, even the solid, tangible objects we interact with every day, partakes in the impermanent dance of existence. Isn't it wondrous how mathematics, a subject often considered rigid and exact, can provide such poetic insight into our existence? In the dance of numbers, we find reflections of life itself. It is a poetic and profound understanding, isn't it? The very numbers that seem so abstract are in fact at the very core of our changing reality. They remind us that nothing is static, not even in the solid world of mathematics. Everything is in motion. Everything is in a dance that is as real as it is imaginary, as tangible as it is elusive. Embrace this understanding, dear listeners, and you will see the beauty in the impermanence of everything around you, even in the numbers that make up the fabric of our universe. Thank you for listening to the iSquared podcast, where the imaginary meets impermanence. Stay tuned as we continue our journey of discovery and wisdom. My dear listeners, as we draw nearer to the conclusion of our exploration today, let us pause to weave together the threads of understanding we have gathered. Interdependence, impermanence, infinity, and imaginary numbers. How do these concepts, seemingly disparate, form a harmonious tapestry? Let's explore. Imagine a spider web. Each strand is interdependent on the others, and if one moves, the whole web dances. This is much like the world of imaginary numbers, where a change in one part leads to transformations in the others, a perfect mathematical expression of interdependence. The spider web trembles with the wind, illustrating the impermanence of existence. But within that impermanence lies an infinite dance, the dance of the atoms, the dance of the stars, and the dance of numbers, all in an endless flow of change, reflecting both the vast infinity and the fleeting nature of everything. So, here we stand, at the intersection of these profound concepts. Imaginary numbers are not just mathematical constructs, they are expressions of a reality that is forever shifting, an eternal dance. They are interdependent, changing in response to each other like partners in a dance. This interconnected dance leads us to the idea of impermanence, where nothing is static, nothing is forever fixed. It is a philosophy that teaches us to embrace change, to see beauty in the transient nature of all things. And finally, the idea of infinity. It is not just a mathematical abstraction, it is a perspective that recognizes the limitless possibilities and endless connections within our universe. It is the realization that in the dance of life, we are all connected, all interdependent, all part of a beautiful, infinite, ever-changing whole. These four eyes are not separate islands, but a united continent, a landscape of thought that invites us to see the world with fresh eyes. They remind us that life is not a series of isolated events, but a complex tapestry, rich in connections and meaning. As we prepare to bring our journey to a close, I encourage you to carry these insights with you. See the dance of the imaginary numbers in the turning of a wheel, the interdependence in the smile of a stranger, the impermanence in the setting sun, and the infinity in the starlit sky. Your world is a reflection of these ideas, an ever-changing tapestry woven with threads of wisdom. And so, my dear listeners, we have reached the end of this enlightening episode, where the infinite possibilities of the mind have danced with the profound wisdom of existence. Together, we have woven a tapestry of interdependence, impermanence, infinity, imaginary number into threads that stretches across the landscape of philosophy, mathematics, and life itself. We have explored the dance of numbers and how it reflects our interconnected universe. We have journeyed through the ever-changing nature of all things and marveled at the limitless beauty of infinity. The abstract has become tangible, and the distant has drawn near, all through the lens of understanding and curiosity. Your presence and curiosity enrich our quest for wisdom. If you found value in today's episode, please share it with others who might also enjoy this journey. Don't forget to subscribe, leave a review, and reach out with your thoughts and reflections. Your feedback fuels our exploration and helps the iSquared podcast grow. As you move forward, my dear listeners, carry these insights with you. Remember, the wisdom we have explored is not confined to this podcast. It is all around you, waiting to be discovered. It only takes a moment to grasp, yet it is a lifetime's journey to embrace fully. Thank you for joining me on this thought-provoking expedition. Until next time, dear friends, continue to explore, question, and grow. Your journey is your own, but remember, we are all in this dance together. Thank you for tuning in to the iSquared podcast. This is your host, Jimmy Lau, signing off. May your days be filled with happiness and wonders, and may you dance in the symphony of impermanence.